We're doing topic 1 now of chapter 6 for Math 105. Here we're working with rational expressions and functions, multiplying and dividing. And these are the topics we will be going over. First, what is a rational expression? Well, I often think of a synonym for a rational expression as a fraction. So this is your old traditional fraction. And then when we start to put letters in the denominator as well, then we get to the real rational expressions, although all of these are. Now, keep in mind, if you have a radical, let me take a step back here. If you have a variable in the denominator, this is not a polynomial. By definition, a true polynomial does not have a variable in the denominator. So this wouldn't be, and this probably wouldn't be either, but it depends. Okay. So if we put the function symbol in front of what we're dealing with, then we have a rational function. And some of the things we'll be dealing with is when we graph them to figure out what the domain of them would be. And sometimes it may not include all real numbers. And you might say, why is that? Because if a value of a variable in the denominator makes the denominator a 0, then that's excluded from the possibilities of what those variables can be. Now, one of the main things we're going to be doing in this section is to simplify rational expressions. And the process we commonly refer to as canceling out common factors. And we'll illustrate that. And a factor that is equal to 1 that we can cancel out. All right, so let's take a look at this one here. Now, as we see it, this is a rational expression. Are there any common factors? Well, if you were to factor the top, you'd see this. And if you factored the bottom, you'd see this. And notice what you could do now. You could actually and I'm looking for my pen here. There we go. Cancel this out because 9 over 9 is 1. X over X is 1. So this would simplify, as you can see here, to X over 4. And they're just putting both of them together. 9 over X, that's 1. So you're left with X over 4. Now often you might say, I can do that mentally. 9 goes into there once, 9 goes into there 4 times, and I can cancel out one of the X's, and that's how you would do it. And there's your answer. So here they're giving us some rational expressions. What would the strategy be for doing simplification? Well, in all of these cases, and reflecting on the work we did in chapter 5, we need to factor them. Now, they have it all written out here for you, but I should do some here too, just to show you. Get a pen going here. There we go. And let's do this one right up here. So in this one, I can factor out a 3. And I get x minus 4. And in this one, I can factor out a 5. And I get x minus 4. Now you see I have common factors that I can then cancel out. So for A, my answer is 3/5. Now here I can cancel out or factor out a 4A. And in B, I can cancel out, or factor out, I should say, a 4A out of the top, and then a 4A out of the bottom. And now it's this part that cancels out, and that would be my answer. And then over in this one, I'm going to factor that. And I'm looking at the signs. I need a plus there and a minus there. And then now I look, I see I have the difference of perfect squares that will factor into its conjugates. I used to put the plus first always, but I see if I put it on top here, this will cancel out. And then there's my answer. So what have I done? Well, I've simplified by taking out ones. And remember, we're going to probably use this technique too later when we have to get common denominators. That's later. Okay, so we'll take a look and see how they do it here. Okay. I like the use of color to indicate now this is going to be a 1 there. And that's our answer. And for C, again, they did it pretty much the way I did it. And that's the final answer. All right, so this is canceling, which is a shortcut that can be used. And of course, it can be misused too, so you have to be careful. And they're just saying this is a 1. You can just cancel it out like we did. Okay. Now, for this one, what you need to do is see if you can actually factor this. And it does factor into this. So again, you can cancel these over here. All right, so that was if we had something and we wanted to simplify it. Now what we're looking at is multiplying 2 fractions, 2 rational expressions. And again, you want to cancel out wherever you can. So let's just do one here to show you the process. So notice I could cancel a 5 there, and this becomes a 2. I can cancel the 6 completely. I cancel the A, there's a 1 there, so then this will become a 3. So my final answer then will be a to the third over 2. And I use the process of canceling to get to my answer. All right, going on to letter B. And again, they're going to show you this in the PowerPoint slides, but I thought I'd work it out for you. All right, so what we're going to do, the strategy is to factor everything we can. So there's x, 4, 1, plus, and here these are the conjugates, x plus 3, x minus 3, and then this is x minus 3, x plus 4. And now what you do is you look around to see what can I cancel out. Well, the x plus 4s, the x minus 3, and then we're just left with that as the answer. Okay? So in multiplying, again, you're going to cancel. Now you could write it out if you'd like. I like the method of canceling. But you need to be careful and neat so you don't make errors. Now that's the long way. And this is what we did after we factored. We will cancel out, and then we're left with that. Okay. Now, here, sometimes they could be a little challenging. So let's do this one. 2 sets of parentheses from our work with chapter 5. I need a difference of a positive 1, so this will be positive and this will be negative. And if I like, since I see the 7 up here, I could do this. 3 times 7. Okay, so there's my 7. Now this one's a little bit of a challenge, but they're not too hard. Since this is prime, we know it's going to be 3x. And we need an 11 in the middle, so this is going to be a 4 and a 1 here. And this needs to be minus, and this needs to be plus. And we FOIL it to check. Okay, it looks good. So, to cancel out then, this will cancel with this. The 7 will cancel with this. And what are we left with? Well, we're left with, on the top, x plus 5. And on the bottom, we're left with 3 times 3x plus 1. Now, you could multiply through, but actually they prefer that you leave it in factored form. And there it is. Okay? Now, remember, you have access to these PowerPoint slides through your math lab. All right, we're now jumping into division. Now, division of fractions is very similar to the multiplication of fractions. Just one thing different, if you recall from an earlier lesson. Here we have a division sign that we're going to change to multiplication, and we're going to take this second term and flip it. that is the reciprocal of this term. Now once we do that and get it into this form, it's then multiplication. We can factor it, cross cancel wherever we can, okay? So let's look at some examples here. So what will this be? Well, this is going to be simply x over 9 times, now as I change that division sign to multiplication and take the reciprocal of this. So this becomes then xy over 72. Now there's nothing that we can cancel, so that's all it is. And this, keep in mind, is over 1. So that just becomes x plus 3 over 1 times x plus 5 as we take the reciprocal of that, x minus 2. Now notice we couldn't cancel anything out. So it's just that then over that. We have multiplied. Now if you FOIL it, that would be okay, but theoretically leave it in factored form. So they're just changing from division to multiplication and then the reciprocal, and you get that. Okay. And for B, again, they're changing it from division to multiplication and flipping the second term, taking the reciprocal. And there's nothing that could cancel out, and they leave it in factored form. Okay, now this one will do. I'll show you the whole process. So this is x plus 2 over, these are conjugates, so we'll factor that, x plus 2, x minus 2. Now I'm changing it to multiplication, so this one now goes on the bottom, x plus 2, and then I'm going to factor this one here. This looks like a perfect square trinomial from chapter 5. So x minus 2, x minus 2. Now we see wherever we can cancel out. This will factor out. And one of these will also. Now, I could have done it here too. I like the idea of cross canceling. That's okay. The answer comes out the same. So my numerator here is going to be x minus 2 over x plus 2 is my final answer. Okay? Again, it's the process we want to stress in these slides. You will be doing the practice, and I'm not going to do every single example, but I want to be sure you know how to do it. So there's division, change to multiplication, then we do our factoring, then we do our canceling, and there we get our answer. All right, now this one is just tedious. Notice you have to factor in chapter 5 just one of these. Now an example here in chapter 6, you have to factor 4 of them. But remember, you're going to change this to multiplication and flip this over before you factor it. And they're just showing you. And there's all the factoring. Now you try to see what can cancel out. Well, I see this will cancel out. This will cancel out. This will cancel out. And you just have these two left. All right. Okay? Can you see here the difference of perfect squares, and some of these factorings are not too bad. And they factored it for us. Be sure to convert from division to multiplication by taking the reciprocal of this second term. And there wasn't too much to factor out or cancel out there. And that's the answer. Leave it in factored form. All right, now going on to the vertical asymptotes. This is kind of technical, so let's read it together. If a function of x, is described by a simplified rational expression, and a is a number that makes the denominator a 0, this is really critical right here, that a is a number that makes the denominator a 0, then x equals a and is the vertical asymptote of the graph. Wow. Well, again, you can pause this and read it again, but I'll show you the example. So here's the function. So what do? Well, we want to simplify this function. So we factor it, and we end up with this. Now, as I said in the beginning, when we are defining the domain of rational expressions, sometimes values of x are not included. They're not all real numbers. Here, what would make our denominator a 0? And you just equate it to 0. Let's just do it here. So x is equal to -4, right? So this is our value that for the domain of this rational expression, we would exclude. In fact, let's just do a little review of that. What is the domain of this expression? Well, it would be all real numbers, but x cannot equal -4, because we saw here that if x were a -4, that would make this a 0. That would make our denominator a 0. Okay? So in this case, what is the vertical asymptote? Well, believe it or not, it's going to be -4. All right, and let's take a look at that in a graph. So the denominator of the simplified expression, x plus 4, is 0 when x is a -4. Thus, x is -4, and that's the vertical asymptote of the graph. Now, where is that? Oh, wrong slide. Let's go back here. Well, it's right here. One, two, three, 4. There's your vertical asymptote, and it shows up really, really well on your graphing calculator. Again, I'm not sure how much they're going to use it, but that's what it is. Okay, we kept this down to a little bit over 20 minutes, so not too bad.